All right, guys, in today's video, we're going to be looking at a couple of Sears Craftsman 19.2 volt Diehard battery packs that have a problem. The Nickel-Cadmium one is the black top, and the Lithium-Ion is a later model that's got red on top. The part number is 315-11375 from Sears, and it has a battery number 1302-79017, at least for the Ni-Cad one. And then for the Lithium-Ion, it's a Sears 315 PP2025 or battery pack 1302-11047. Let me put these two on the charger and I'll show you the behavior they have. If we take the lithium-ion one out and we put the nickel-cadmium pack in, it'll flash more rapidly, which is what you would normally expect, and then it'll quickly go into defective mode, where both green and red flash. So the Ni-Cad, the charger is able to detect is defective, probably because of a shorted cell. All right, so whereas the nickel-cadmium one is actually defective, we're going to rebuild one of these lithium-ion ones just to get more capacity out of it because it's tired. This one still charges, but it doesn't last anywhere near as long as this one. This one's about a year older than this one. So we're going to rebuild this guy in order to get him back to where he can last longer, but also even longer than when he was new, because we'll use a higher milliamp hour rated cell when we rebuild this. All right, so to open these up, the Ni-Cad types have 5 tamper-resistant security torque screws in a T10 size, and the lithium-ion ones have 4. If we zoom in here on one of these, we can hopefully see that there's like a pin right in the center. And so the type of Torx bit you would use, it's easier to see with these larger ones, has a hole in the middle to accommodate that security pin. You can't use a regular Torx. So we're just going to use a T10 with this little hole. Hopefully it's coming out in the camera at the end of it so to clear this pin. And this is for a genuine OEM type battery pack, right? Not some Chinesium one. And we're just doing this because I'm not interested in using one of these Chinesium knockoff packs. We want to reuse and repair the OEM packs. So just going to take all these out, and bear in mind as I do this, there's a gap on the front here, so I think at some point this pack got dropped, and so this here is probably loosened up, and I think this one here also got dropped. So there's going to be some possible little pieces of plastic inside, just pointing that out to you so you don't think that has anything to do with the problem. I think these have been running just fine for years since those impacts. We'll take this Ni-Cad one apart first so you can see how they differ internally in design. Obviously they differ by the type of battery technology that they use. And then I'll show you how to rebuild each type. We're not going to convert anything, and we're not going to modify anything. We're going to rebuild the nickel-cadmium one with nickel-cadmium cells, and we'll rebuild the lithium-ion one with lithium-ion cells. That way they'll remain compatible with our OEM charger. All right, so as I suspected, this one's kind of got some impact damage where it screws in. At least it's behaving like it does. Can't get that out there. Let's see if we can just separate the top and see what's going on with it. Yeah, there's the screw. All right, so the screw looks okay. We can see where the nickel-cadmium cell has exploded. That's what's causing the problem. And that is just bulging, so that's why we have the problem. So fortunately, nope, I was wrong. There is some crackage if we zoom in from that impact damage right there. All right, so we can see these cells though. Let's see how we might get this removed from here. There's our pack. There's our broken piece to the plastic where the screw goes. We'll see if we can do something about that later. Just want to first see what we've got here. So these look like sub C size paper bound cells. They've been spot welded to this base plate. I think either that or there's pieces of metal under this base plate. Yes. All right, good. That's great. So we don't have that. We just have these little things here. So all we're going to do, we're not going to try to see if any of these are any good. With damage like this, I'm just going to replace them all. So what do we need? 2, 4, 6, 8, 10, 12, 14, and then this would be 15, 16 cells. So we need 16 Ni-Cad cells to repair this. So that's one thing we need to do. Very messy. Let's set this guy aside until we can order the parts to rebuild it. Let's do the lithium-ion one next. Same size, fastener. The screws are different though. The lithium-ion screws are shorter than the type used in the nickel-cadmium case, so they're not interchangeable. All right, this design is going to be different. This one's more complex because there's a circuit board involved. But we can see the lithium-ion cells arranged in their pack. Let's see how best to remove this. Got to get these little red release levers just to kind of slide to the side as we take this out. All right, one of them popped off. We'll go find him later. All right, and then 2, 4, 6, 8, 10 standard type cells. So we'll get these ordered as well, spot welded on the ends. So we just have to pull off all these spot welds. And again, I'm not going to bother testing to see which of these are bad. We're just going to replace them all. It's the fastest and easiest thing to do. All right, so let's get these parts ordered. When we get the cells, I'll show you how to disassemble, remove the old cells, put the new ones in, and we will be doing the same factory type spot welding to rebuild it. All right, we're going to start with this lithium-ion pack. The first thing we got to do is we got to get these spot welds off of the existing cells. So there's a couple of techniques you can use. I'm going to start with just trying to pry them off. I'm just using a little 45-degree angled pry bar here, a little mini pry bar. I'm starting with these positive ones just because that'll let me know what I'm dealing with here, because I can get the tool in better than on the negative ones. I'm just trying to see how strong these original spot welds are. Will we be able to just break them mechanically? Because we'd like to salvage the tabs to use for the new ones. All right, so I heard that one pop. Just as you're doing this, right, you want to be careful that you don't hit anything else. All right, so we can mechanically separate these just like that. And then eventually what I'll come in with when we're all done, I'll show you here, I got a pair of pliers that have no teeth, right? They're flat. And I can use something like this to squish down those solder joints, those weld joints. So I'm just going to go through, it's kind of tedious, but we're going to go through and remove all of the positives, and then we'll swing back and do the negatives that are harder. Now what if the penetration on this weld was such that I could not get it off mechanically? Well, then what I would do is I would take a worn down Dremel cutting bit and I would come over. You can see there's a raised edge where these things fold down, right, all along the edge, and I would just cut them here, 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 all the way on both sides. And then we would spot weld a new tab strip from the primary strip to the battery cell. But it looks like we'll be able to get them without any cutting. I don't like doing any kind of drilling. If you do accidentally happen to go through and penetrate the cell, then you run a risk of some of the toxic chemicals that are inside getting out. So I just prefer to try and do it like this. So I'm going to go through, mechanically separate all of these, and then we'll come back. All right, so we're about halfway done here. You'll notice that one side, there's 2 pairs that have positive terminals on the cells, and 3 pairs that are negative. And if you flip it over, it's exactly the opposite on the other side. So here we have 3 that are positive and 2 that are negative. So we just have, I'll show you these last 2 that I have, this last cell here on the positive side. I did want to show you that on this particular one here, it's just a little bit different than the others. The others are like this little T shape. This one's just a single, so it's okay that it comes loose. It'll be resecured when we re-weld it. So again, just showing you the same technique with the same tool. I come in on the side that's got the most metal. And you just want to make sure you keep control of the tool because you don't want it to slip over and hit this terminal, right? So it's okay. This is all welded together with this one piece, so nothing's going to short here. And we're just going to give it these little wiggles that's going to cause metal fatigue at the spot weld. That one's off. That one's off, right? That's all you have to do. Come at this one on this side. That one's off. And then we can slide under from this side on the one we already got. We're just being gentle because we do want to try and reuse this. All right, so now we're done with the positives. I did the positives first just because the shape, the tool gets in easier. Now the negatives is the same technique, but we don't have any way to get underneath immediately. So we're going to have to make a little bit of a rise. So I'm going to use a little pick like this. Right, I'm just going to come under both of these that have been spot welded so that we can get the tool underneath. And then it's the same technique. And this wiggling back and forth is important because that puts stress on the spot weld until it gives way. And you do need to work them in pairs. That one's off. That one's off. Now on this one, I might need to raise this back corner up. Let's see. Nope, it popped off. So we're going to do that technique, and we'll finish all the negatives. This negative here has a little insulation strip covering it. You want to protect this strip. It needs to be reinstalled. But then it's the same underneath. There's no difference. Right, so we'll come back when we get through this side and I'll show you one more. All right, we've got everything off but this one under here. And this is, we're going to stop for a second because we've got this one kind of dangling around. We want to secure him. So we're going to use that technique I was telling you about to kind of flatten everything back out. I'm not trying to get it perfect right now. We can do that after we get the cells out. Just want to get it a little bit where we expect to have it. The main reason I'm doing this is now I want to secure this so it doesn't accidentally flop around when we flip. All right, little glitch on the phone, guys. And now we'll just be able to make sure that if this flops around, it doesn't touch anything and short anything out. This is the only one that you've got to worry about that. All right, now we can continue. All right, another little thing over here, guys, I wanted to say when we're working with this one that's under this little insulating pad, that's also the location. If we zoom in here, this little black item is a temperature sensor. So we don't want to damage this. It kind of moves around. So as we're working on this one, make sure you don't damage the temperature sensor. All right, last side. We've gone ahead and did the same treatment on this end piece with tape. We've got this middle one all done. And again, I just told you I'd show you guys one more of these negative ones. Just going to pry this up a little bit more with our 90-degree pick so we can get our little mini pry bar tool underneath properly. And we're going to do the same little wiggle technique to weaken these spot welds. You just got to have patience with this if you're going to expect to reuse it. Okay, that one's off. And that one's off. We're done. At least we're done with mechanically separating the spot welds. Now, one thing I didn't tell you that I want to tell you now, it's obvious on this end you want to try to avoid shorts. You also want to avoid shorts between these two here, right? So when you're working on these middle pieces, right, it's good to put a piece of paper down here or a piece of electrical tape when you're prying up on these so that you don't accidentally short anything. I should have mentioned that previous. It's kind of common sense, but I just want to make sure I'm explicit about it. All right, so now with all of these in a situation where they're no longer mechanically attached. Actually, I thought I got that one. One more. I could have swore we finished him. There he is. All right. They're plastic welded at the top, and we kind of want to retain that as much as we can to help hold it. So we're just going to try to move these up a little bit. This one's already kind of in that position. We're going to come over here and do the same thing on this side. Just move it up a little bit. Now this one's got a little bit of a plastic weld here. We're going to have to sacrifice that one. It doesn't matter. This is where you find out where you thought you were done, and might be a little piece still hanging on somewhere. All right, so now we got to get one side. It doesn't matter which, but we got to get one side of this plastic holder off. To do that, we're going to have to come in with a screwdriver where it's attached to the circuit board. So I'm going to remove this screw. Be careful you do not slip with the screwdriver and damage the board. All right. So now we just got to kind of figure out what else is holding this on other than just the friction of them being inserted. I'm going to go ahead and take the two screws off the other side too, just so we get some maximum flexibility to find out where this wants to be weak. These two screws here you leave alone. They're holding the heat sink for these two transistors up here. MOSFETs probably. All right, so board's loose. And this little tower pops in here and here and Should be just on this side, but it's a little bit stuck on that side. They might have glued that one. It's okay. I think with what we've done here, we have enough. So what I'm trying to do is see underneath to make sure before we give it any kind of force that nothing's attached between the two pieces. So at this point I think it's safe to pull this off with our little temperature sensor. Try to find any more pieces like that that we're holding on that we didn't notice. All right. So now I'm just looking for a good place to separate this. This is the first time I've tried to open up one of these lithium-ion ones. I've did the Ni-Cad ones before. This one's a little bit new. All right, so this is just friction fit. This all comes off. Great. Just got to be super gentle here. We're trying to figure out what's holding the board on still. So it's not this circuit piece, and it's not this circuit piece. There it goes. All right. So this was just a little bit wedged in. All right, so now we can confirm that there's nothing holding these batteries together but the friction fit of each end into this white plastic. So we don't have much play with the wires, but we've got more play on this side than this side, so this is the side that we'll aim to separate it. It might be glued. That also could be a possibility. Let me get a different kind of prying tool, a little bit longer, so that I can see if there's any glue or this is strictly a friction fit. It's hard to tell. And again, I don't want to force it. So they're not glued in. So I'm not really sure what's holding it. I really didn't want to do this, but we're going to have to separate these plates off. So these plastic welds, there's two ways you can do it. You can either break the plastic welds or you can desolder the lines from the circuit board. I'm going to choose just to break the plastic welds here. Make sure you wear some eye protection because sometimes a little piece of plastic can go flying. Just trying to be gentle with the terminal. Come on. There we go. And then I just want to mark where the blue went. So we know the blue one goes there. We can orient this back the way it's supposed to go. Right? And this way, I can kind of fold this back and out of the way. And then let me get some more force going here. Just want to make sure nothing touches until we separate this off here. Yeah, that's really, really on there. Not sure if it's like they snap in. Let's just take the whole thing off to avoid any shorts. All right. All right, so guys, I noticed when we get a punch in here, we're only going in about that far and I hear a metallic sound. So the problem is there's a fastener holding these two halves together. If we look down in there, I don't know if you guys can see it. It has too much glare with the flashlight. But there's a little, there he is, there's a little Torx fastener sitting in both of these crevices. And it turns out to be a T10. So if we can get a very small Torx in here, and undo this little fastener, we could have avoided taking off our circuit board if I had caught that earlier. Come on. There he is. All right. 1 and 2. I guess we would have still had to take the board off, because in order to get one of these ends off, since it's got this kind of a design, we would not have had enough slack on the leads, right? Because this is going to be long, I bet. Yep. Yeah, so we still would have had to take the board off to get this separated. All right, so finally, we can move on to the next step. So the cells that are in here are LG Electronics cells, and these DAHA 11865 parts, this translates to a 1300 milliamp hour device, or cell rather. Date code of R144, 144th week. R would be 2018. I bought these in the Sears store before they went out of business in 2018, so that makes sense. 1300 milliamp hours isn't available anymore. It's too obsolete. So what I'm going to replace this with are some Samsung cells, INR 18650 25Rs. These are 2500 milliamp hours. This will be an upgrade in the capacity of the pack. The date code on this guy is, let's see, T would be the Tianjin, China factory. 6A would be June 10th. And P would be 2025 or 2024. Not sure. There's different documentations out there, but they've changed their date codes. All right, so we're going to take these cells out and just swap them in using this little case thing as a holder. These cells, these Samsung cells, I went with these because they were only $2 and I think 79 cents or 59 cents, I forget. Under $3. All right, positive and negative. So we're going to take these guys out in pairs. So negative, positive. Positive up for that pair. And this pair is going to be negative up. And this pair is going to be positive up. Negative up. And positive up. So why don't you test and find the bad cell? Why bother? The cells are from 2018. Average lifespan is about that much time. Maybe if you're lucky, you can get more. 10 years would be the absolute maximum. Let's just put all fresh cells in here, and the pack's going to end up having greater capacity than it started with. Whoops. Dropped it in the wrong hole. This one and this one. So it'll be far superior. And at the price we paid, we're replacing this for under $30. And we're replacing it with genuine OEM type batteries, not some Chinesium, possible fire hazard. I would only use cells from LG, Samsung, Panasonic, maybe Sony. And we can still get an economical upgrade here to 2500 milliamp hours. And it should be good for another 8, 9, 10 years. Okay, those T10s are back snug. Just as a double check, we'll use our little things here. So we said that we would have positives here, negatives here, positives here, negatives here, positives there. Negatives, positives, negatives, positive, negatives. So we're good. We're good to go. Now we can bring this guy over. And I'm going to finish prepping these leads. right? So we're going to come in here with our flat-bladed pliers, like I mentioned earlier. And we're going to flatten all these out. Just like that. So I'm going to do the rest of these off camera. We're going to get them all done. And then I'll bring you back when I've gotten all of these flattened out. All right, we've got these guys all flattened again. There's two other things we need to do here. We're going to take a small paper towel, put some isopropyl alcohol on here, and get our skin oils off of here, because tin will tarnish pretty quick just from you touching it. A lot of times you'll get on tin, you can even see it here where it's starting to show a fingerprint outline. All right, the second thing we're going to go do before we weld these back together, I should have probably done this before we put them back in the holder here, but what I want to do is I want to see what the voltage is on these brand new cells. So negative to positive, 3.57, 3.57, then I'm going to skip down to the next ones that fit this orientation, 3.57, 3.57, 3.57. They should all be about the same if you get them from a reputable supplier. Do these ones we skipped. 3.7, 3.57, 3.57, and 3.57. Why do we do that? Well, before we can start welding to these cells, we've got to make sure they're within 0.4 volts of each other, and that was the check we were doing there. All right. Now we're going to come back over and get this thing oriented back in. And to give it some stability, we'll put these screws back in that secure the circuit board to this holder. Almost done, guys. If you could still go into a Sears store, or even if you could go into a Lowe's, it's handling the Craftsman brand nowadays through Black & Decker, and you could buy a brand new OEM 19.2 volt battery, I wouldn't bother with this. But you can't, and that's why we're doing this. Get these little tower guys back in their holes. Get that back where it goes, and then let's get started. So this wire fits in there. This wire's the temperature sensor. It's going to be there. This wire fits in that little crevice there. All right, just like that. And then we're going to bring over our spot welder. All right, so we've got the welder where we can reach over and get to it. We got these two guys here. Let's go ahead and peel off the tape we put on this tab as well. And then make sure we've got these good and flat. So we're going to end up putting these just like that. All right, the thickness on these tabs is on the higher side. If we use the other side, we can just use this guy right here since he just popped up and volunteered. 0.25 on our caliper there. So 0.25 is going to be too thick for a lot of these battery-powered spot welders, so we're going to have to use the desktop one. This one here is a CSI SC203, I think. I'll put a thing in the bottom of the video if I got the number wrong, but I think this is a 203 model. So we'll go ahead and use that to do the welding on this side, and then after we get everything welded on, you can see in the back here I've got a little plastic welder. We'll come through and we'll redo the plastic welds to kind of hold this stuff all together permanently. All right, we're going to start off with a 2.0 setting. I don't know if that's going to be the right one to use for this thickness. We may have to jack it up a little bit, but we'll start with that and we'll see how it goes. It's probably not going to be enough. This one's got a little bit of a bend to it, so that's why I want to do it first. Nope, not enough. So let's go ahead and crank this guy up. Let's try 3. We'll keep that to just a little over a second, and let's try that again. Once we get it dialed in for the thickness of this material, we can go a lot quicker. So I'm going to kind of hold it down on this side first because that's where the little ridge is, where it's bent. All right, that held it, but that's not the kind of penetration I want, so we're going to go up to 3.5. We'll leave the rest of that alone. We'll try it again, see if we can get this dialed in. Better. Still not what I want though. Let's go 4.5. Even better. Let's just go to 5. Let's see if we can get the right piece dialed in here. Accidentally took it off of the auto trigger. All right, let's go over and do this one at 5.0. Much better. Still like to get a little bit deeper. Do 5.5. Yeah, that's much better. I think we'll go with 5.5. Just going to push this bent part down first. Going to redo this one. All right, those are nice. Let's grab this guy here. Let's grab this guy here. Let's grab this guy here. Actually, I'm going to go just a little bit more. Good. The thing is to try to get it as close to the penetration of the original one without burning a hole in the battery. Come over and do this guy now. Yeah, I mean, 6.0 on this thickness of material is probably fine. But just to do this last one, I'm going to inch it up just a little bit more. So I feel like we got a little bit more headroom. We'll go to 6.2. Oops. This was kind of crooked. Yep, I think that looks fine. All right, we'll set this guy aside where he doesn't touch, and then we'll come over here and we'll take the plastic welder, and all we're going to do with this guy is where we have these pieces of plastic that are still left, right, we're just going to come in here and smear them down to help hold these tabs in place. Almost got my finger there. Trying to not touch the rest of the plastic, causing me to jitter this guy a little bit. Okay. Now we can do the other side. Same deal. Fit those in with the plastic pieces. Peel this off of here. Come in and flatten these out. And then we'll just repeat like we did on the first side. Doesn't matter really where we start. We'll just start right here. Okay, and now this guy here. Ooh. Let that touch the edge, my bad. Didn't damage the battery though. The reason you saw more of an arc there was that the thickness is set right now to include the tab, and that part touched the battery without the tab in the way, so it's not thick enough for this much current that we currently have it set for. Also trying to make sure we didn't miss any, so these are all solid. Yep, okay. And this is our last one right here. Okay. Same thing with the plastic welder again. That tab right there. Here. 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 And here. Okay, then we're going to put this little temperature guy back where he was. And there was a little padded holder for him. And then we had this piece of tape that also helped hold him in position. And make sure that these wires are fully seated in these grooves for them. Whoops. And this one here. Okay. Now we're going to set this guy back in the base. This button to fit back in here, and it looks like our little, I don't know if I like how this little pad keeps popping off. Take this guy back out and fix that. Might want to put a piece of electrical tape because this just you know, the adhesive is just given out on this. Trying to see, how does this go? Goes like that. Okay. Okay, we got it in there now. Guy's in there. That guy's in there. All right, let's see what we've got for voltage with everything connected correctly. Should be positive on the round side and negative on the flat side. We're reading 17.6 volts. It tells me that we've got everything connected properly. Put these screws back in. Snug them up. Put them on the charger. And we're ready to move on to the nickel-cadmium version. All right, you don't want to over tighten these because it's plastic, right? Make sure the two release buttons look like they're working okay. Good. All right, so now hopefully you guys can see over here, we'll take the battery that we had in the charger that's charged. Remember that when you see it all green, it's fully charged, and when this light's out, there's no problem. So we're going to take this guy out. This was the one that was okay. Now we'll take this one we rebuilt. Make sure we get it to seat properly. There we go. Got to flash fast to know that we got it seated properly. And now it's charging. So we'll go ahead and let it charge up, and we'll remeasure the voltage, and then we'll give it a test. While that's happening, we'll go ahead and clear off our bench and get set up to rebuild the nickel-cadmium version. All right, the nickel-cadmium one is not going to be as much disassembly as the lithium-ion. We're going to set this aside and clean it for all the electrolyte that ran out. And we're not going to disassemble all of these cells. We're going to make up our own replacement tabs in this case. So the only thing we got to do is take this spot weld off. So what you have here is a soldered on terminal to a spot weld on this one cell. And this is a pretty hefty size material here. But same technique we used on the lithium-ion, it's just this is a little bit messier because of the damaged cells. So I can't really grip it as much as I'd like. And I can also tell this particular weld is a lot thicker, a lot more penetration. But the same technique of wiggling it back and forth will separate it. It's just basic metal fatigue. And I just want to retain it because we're going to need it. Okay, there's that one. Nothing else on the bottom. This little tower here, we can see behind the tape is a sensor, so we're going to take that out. This spot weld on this cell we're also going to need to separate. Now this one's got some electrolyte material, I should say. So as you do this, you want to be real careful you don't flick this stuff up into your face. So we're going to try to hold this cell, keep it gentle. The same technique. We're going to wiggle this stuff off. This one is just pretty far gone. So there's not a lot I can pry on. I don't know if you guys can tell, but the electrolyte has damaged the side of the cell, and so it's all smushy, so you can't really pry up against it. So the only thing I pry on is the top of the cell, the button. Man, these are some much better welds than were on the lithium-ion cells. Okay, there's that one. And in an example of do as I say and not as I do, you should really have some gloves on because this material is toxic that has leaked out of these damaged cells. Just got this one little tab here, holding on for dear life. Now, if you don't want to salvage it, you could of course cut this. But I prefer to try and get as much of the original tab in doing one of these rebuilds as I can, just in case we have to cut it anyway. All right, there we go. Now we got this little tray here that this sits on to insulate it. And then we've got what I think is another sensor. Let's see. Peel this tape off. Peel this tape off. And then take this insulating gasket out. We can see what's going on here. So what do they got going on here? So this is tucked down into, this is another sensor. So there's like a little wrapper around this one particular cell hosting this guy. Temperature sensor. All right, and that's it. We're not going to disassemble any more of this. This is all just going to go, we're going to clean it up a little bit and take it to recycling. Hopefully they'll take it. What are we going to replace these with, right? So we know these are nickel-cadmium, but this number means nothing. But we can tell that these are paper-wrapped sub-C cells. They're just about the size of an alkaline C cell. And we're going to replace them with something like this, right? So Tenergy is the company I use whenever I rebuild nickel-cadmium batteries. Don't get any of this no-name, Chinesium stuff. Although stuff may be made in China, there's a difference between made in China and Chinesium. So Tenergy sub-C batteries are what we're going to use, and they're going to be an upgrade because these are 2200 milliamp hours. We need 16 of them, so we got a box of 15 and then one extra left over from when I did this before. And what we're going to do here is we'll take these out of the box and we'll start to replicate the setup we've got here. So we've got one like this, one like this, one like this. All right, you guys get the idea. We're going to replicate what we see here in terms of orientation and polarity. And then we're going to come in and make our own strips and spot weld them in rather than messing around trying to salvage these other ones. This is so bad it's hard to tell if it's positive polarity, but yes, it looks like it is. Looks like the one next to it is, and it looks like the one adjacent to it is. And it looks like this one is not. This one is not. And this one is not. And this one is. All right, let's just kind of double check our work here. So we've got positive, positive, negative, 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 positive, positive, negative, positive, negative, positive, positive, negative, positive, negative. And then what we're going to do is we're going to come in with just some nickel-plated steel, and we're going to come in here and make strips that are the same size as all of these, and we'll spot weld them on, and then we'll flip it over and we'll do the other side. All right, so we cleaned up our insulators, and that's a good thing that we can use to see that we've got the correct shape to sit in the pack. I move these cells around just a little bit to make sure that this fits evenly. And then we've cut these little strips that we're going to start spot welding on to take the place of what was originally done in the original factory one. And then we'll do this single standalone cell that sits on the tower last. All right, so we're going to use the same spot welder that we used before, but this is a lot thinner, so we're going to have to go back down. I'm going to take a guess. We'll start at this setting and we'll see what we get. And we're just going to replicate each of these connections, starting with this one. Very nice. It's always good when you see sparks. It's going to be a good penetration weld. All right, I'm going to the next one. That's going to be from here to here. And then we're going to go here to here and here to here. Another tip is when you're doing something like this, you just want to press lightly. Don't want to press too hard. Just doing extras on these just because we got the space. Okay, and now this guy here. And this guy here. And this guy here. You guys get the hang of it? And last one, here to here. Okay. Set our terminals down here for a second. So now we're going to do this one last. Remember, there was this tab we separated here. That's going to have to be one that goes from the bottom of this cell to the top of this cell, right? So we'll do that one last. Now what we're going to have to do is flip the whole thing over. So check your work, make sure you've gotten everything that you need to have. And we're going to flip everything over and do the bottom. In fact, I probably should go ahead and get the tape on here. Yeah, let me go ahead and get the tape in place so this thing doesn't move as much. So we've got an insulator that sticks to the side of this tape, but the main purpose of this tape is to hold this shape. So just go ahead and get it back the way it's supposed to be. And then let me go get some tape and run it along the edge. All right, we'll come in here. About the same position that they did it originally. That's all it is. It's just to help hold the shape. In fact, we probably could just use what we have left over here rather than cutting a new piece. Okay. Now it's easier to hold and manipulate this while keeping it in the same shape. So it'll fit in the housing. Okay, same thing, different side. We'll start here. Notice doing these, I'm trying to close up the spacing, make it a tighter pack. And again, that's to make sure that it fits in the housing. Just kind of squeezing them together, taking the slack out from in between the cells. Squeezing it together. Squeezing it together. This particular strip's got a little bit of a kink in it. We'll have to flatten out. If you need more time to get things fixated, that's the delay that's on the spot welder. This value over here I've currently got set to 1.2 seconds. You can increase that if you feel like you need more time to line things up before it auto fires. The trigger for the auto fire on this model is when it detects that it can see there's current going between these two terminals. That's when it knows to go ahead and trigger the firing. 1.2 seconds later on the current setting. Okay. Check our work. Here, here, and here, 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 and here. Right, we're done. Now, we got this tab from this assembly is going to end up going down here when we're done, right? Because that's where we took it. So now what we want to do is we want to take this out. Well, maybe we'll leave it in there so we know where it goes. All right, so we got to get this cell out of this little tower assembly here. So let's see how that's done. So looks like it's just a spot weld right there at the top on the positive terminal. Okay, don't have a lot of room to work in here. But we're going to see if we can do the same thing we've been doing, right? We're going to see if we can pry this spot weld off the top of this cell. If we can just get it up enough to get the tool in from the side, we might have a chance to pop this. All right. Again, we've got the kind of exploded cell thing going on here. Some of it's paper mixed with leaking electrolyte. That's what we're looking at here. This is not like acid or anything like that. All right, so I'm going to try to pop the spot weld off the top of this subsea cell very slowly so that I don't flick all this crap towards my face. And we can weaken it a little bit more by pushing it in and bending it out, right? These original spot welds that the factory used on these particular cells are very good penetration. going to take us a while to weaken this one because we can't get any leverage. After this, we're done. This is the last thing we have to spot weld is this cell. Now normally I just cut all this out on the video. I'll speed it up when I do the editing for you, but I figured it's worth you watching. This one is a bit of a pain to get to. You can see now we've got it down enough where we can get some more leverage, hopefully. Just trying to slowly weaken this guy because I want to salvage this terminal. All right, this one is being super stubborn out of all of them. Gonna need to get a pair of pliers. Let me go grab a pair of pliers so I can finish this off. All right. There we go. Now let's prep this. So we just want to get a rough idea for how far over we need to go. Don't want to touch these together, but okay, there's that. So that's this. So now we are done with this. I want to come over and clean all this crap out of here, which we won't bore you with filming, and then we'll get this ready to spot weld on top. And then I think what I could also show you before we stop is, so this is the bottom. So we could come under here and do this guy. This guy's a little bit on the thicker side. We're probably going to have to up our power. Let's see. So I'm going to do it like this so that we can hang this over the edge. Yeah, we're going to have to up the power to go through that thick tab that's on there. Let's try 4.5 on the heat setting. Nope, going to have to go even higher. Let's go 6.2 like we did on the lithium-ion cells. Wow. That is thick. Okay. We'll walk it up to 7. When you're doing this kind of stuff, right, you just want to be methodical about it so that you don't make it too high such that it burns a hole through the cell. If you get it too high, and instead of spot welding, you're going to be melting. Nope. This is unusually high. So this particular terminal is 0.5. That is really thick. And that could also even be a little bit more, because depending on where I squeeze it, you can get 0.6 around the crease. And the piece we're actually trying to hit, .7. Yikes. All right. Let's go. How high does this thing go? So this thing goes up to 25. 25 is its max setting. Let's try 22. We'll leave the same delay. A live stress test for you guys. Not even planned. Oh, that's why it's not doing anything. I accidentally set it to the foot trigger. Okay, my bad. Let's try that again. Well, that was noticeably more powerful. Let's see if that penetrated. Yep. All right. So to get through 0.6 or 0.7, we've got to go up to a setting of 22 on our spot welder, but it can do it. It can do it. Yeah, that's on there tight. We're going to have to clean that up before we put it back in because there's so much oxidation on it, it's going to lead to corrosion. All right, now let's flip this stuff around. Well, that's hot too. All right, so we've got this setup to do. And that's going to mean we want to get this in place. And then we've got this sensor that used to be wrapped up against the side of this battery here. So we are going to replicate that now, but we're just going to use some regular tape. It previously looks like it was vinyl heat shrinked on there. Doesn't really matter as long as it's making good contact. Oh, whoops, I completely forgot we needed to clean all this crap out of here. Yeah, let me go do that. No reason to hold you guys up for that. We're going to clean all this electrolyte and dried up paper pieces out so that we can spot weld this last piece. But it looks like this top one's going to have to hit with a 22 also. All right, if you guys remember, it was this third one back. It had that vinyl piece holding this temperature sensor. So we're going to just take a piece of tape here. Kind of contort this guy down. Actually, going to make it a little smaller. All right, and we're going to put it up against this same sill. Nice and tight. Hopefully you guys saw that, right? So we're going to squeeze it in here. I can't really film it in because we've got so much now that we're trying to pack in here. I'm just trying to get that tape to hold that sensor just like that. When we get this pack ready to be done, get this piece in here, get this piece like this. All right. Now we got to take this guy, and we're going to end up wanting to, he's going to sit on this little insulator, and he's going to get spot welded on the back here. So let's peel the tape we did on here off, just a little bit. Now we're going to have to lower this back down from 22 to where we had it before, which I think was 6.2. Auto trigger. Okay. All right. We're almost done. So now we had a problem. After all that work to try and salvage that tab, when I went to straighten it while we were cleaning, it broke off. So what we're also going to have to do is we're going to have to put a little elbow piece in like this, right? That will spot weld here at the 6.2 setting, and then we're going to have to use the 22 setting to get to fit on our positive terminal here. So to tighten up stuff a little bit, we're going to go ahead and transfer this and this. You could just use some spray adhesive on here, but we're just going to use some tape. It was originally held on with some type of adhesive. Because once it's sitting inside the plastic, it's going to be in there pretty tight. And this was originally held on by tape right here in the front. Just to keep that there. And then I said we were going to put this little elbow on to make up for the fact that we lost this terminal on the front. So we'll do that here real quick. Okay, got this little tray that this guy sits on. And we're going to want him to get up like that. And now we got to fix this problem. Without shorting anything out, and press this down all the way. So we definitely don't want it to go up too far or it'll interfere with the charger. So I think we're going to have to cut this down a little bit. All right, I ended up redoing this repair to loop it over like you see here. I thought this would end up avoiding us having to possibly short something out trying to get the welder tips inside here. So now I'm just going to kind of reach in and push down all the slack of this second terminal tab we did. And what we'll do is we'll spot weld it on this side. So 22 should once again be the spot welder setting for this. And I think I'm also going to just put some more adhesive on this because I don't like how this keeps coming off. Let's see if we can move this a little closer just because of how the length of these leads are. And hopefully I can one-hand this. Until we get the first one on. Actually, that may be plenty right there. So we cut it so that it'll fit in the charger. I think that'll be fine right there. That's it. We're done. So the only other thing I want to do here, like I said, is I want to put some adhesive on this since it just won't stay. And then I'm going to go ahead and get rid of the side tape and put adhesive on the way it was originally done with these side pieces. And then we'll drop it into our base. Let me go get some spray adhesive and we're just about done here. All right, let's get our bad cells and our debris out of here for a moment. All this toxic material. And then we're going to take the base and we're going to use some Super 77 as a spray adhesive. And we'll use that for this piece. And then we had one more on the other side. I just think this will end up being better than what we were trying to do before. Okay, we'll bring this guy back over here. Take off these pieces we put on to keep from shorting anything before. And then I think we're going to have to live with the top piece the way it is. All right. And we'll just glue this on there. And we'll glue this on here. And we'll flip this over. And we'll glue this on here to keep all that together. And then we'll drop this whole enchilada into the base. I think that's how it goes. I honestly don't remember, guys. Does it go like this? I think it has to, just because of how the fitment is on everything. But you know what? I'm going to have to go back and check to see which end was what on the nickel-cadmium one. Let me go back and check the footage, but we'll drop this in here. We also epoxy repaired these two screw bosses. All right, yep, we had it right to begin with because there's really only one way it can fit in. So now we just need to get everything to get in past these pieces of plastic, rather. Tape is caught on one of the screw bosses here. Got the same problem on this side. All right. Need to find those two little red levers. Put them back in. Okay. And then we got to take our top. And hopefully this is going to come through. Okay, I can see that I'm going to have to bend it just a little bit. Good. Yeah, she's stuck on something on this side. Temperature sensor wire is in the way. Okay. What we're trying to do now is there's little pegs that are supposed to fit between the battery creases. Let me show you. So these pegs where the screws go through, we got to fit them in past these same problems with the tape. Just make sure all that's out of the way and not catching them. All right, let's try it again. Okay. And now we had 5 screws for this one. Just want to get all these started. Make sure nothing's binding. Since our repaired ones will be weaker than original, make sure our buttons are working. Since I don't remember which of the two were the repaired ones, I'm going to hold off tightening them down because I want to let that epoxy have a long time to set up. Let's go ahead and see what voltage we're getting. Just after having finished rebuilding it, 20.74 volts. All right, so everything is correctly connected and wired up. As soon as our lithium-ion one finishes charging, we'll put this guy on the charger, we'll tighten down these 4 screws, and we'll give it a test, and we'll be done. All right, guys, this JB Weld repair worked out great. We waited for it to set up, and we were able to tighten all this fastener. So now let's charge this guy up. Our lithium-ion one is done now. We'll measure the voltage on that. Now we'll put our nickel-cadmium one in there. Make sure it's happy. Yep. It's charging up, so we'll let this guy charge up. Let's see what voltage we got on our rebuilt lithium-ion pack after fully charging it. some slack on the lead here. 20.35 volts. That's great. And we had previously charged up the other one that we did not rebuild. 20.28 volts, 27 volts. Right, so that's definitely a good rebuild, and now we'll have a lot more capacity because these new cells have a higher milliamp hour rating. So we went from just the 1300 milliamp hour rating up to these 2500 milliamp hour rating ones. All right, so we'll let this guy charge up. We'll see when he's done. We'll come back and take a measurement of the voltage there. We'll do a quick test of both of these, and that'll be it. All right, guys, we're all charged up, no errors. Let's see what voltage we got out of this at the end. 22.4. All right, and then here's our rebuilt one with our chip. We'll probably put some JB Weld to seal that up so no water gets in there. These primarily get use in impact drivers. Now this one with the spot weld repair. It's working just great. So, kind of a long video, but we got to cover two technologies, lithium-ion and nickel-cadmium. Both are very straightforward to rebuild. The cost of rebuilding this, I think I mentioned earlier in the video, we had 10 cells at just under $3, so figure around $28, $29 to rebuild this plus our time. Of course, you do need a spot welder to do either of these, but I rebuild all kinds of battery packs. It pays off after a while. The nickel-cadmium batteries, we needed 16 cells, and I believe the cost on this ran about $30. I have to go, I'll put links in the description where you guys can see where to purchase these types of 10-energy batteries. But if you got questions or comments, leave them below and I'll try to help. If this saved you some money or helped you learn how to do something yourself in rebuilding these battery packs, pay it forward and hit that like button. I'd really appreciate it. And as always, thanks for watching.